Hello students, and welcome to this lesson on cubic function transformations. Last time we introduced transformations of cubic functions, but today we're going to go a little bit more in depth. Alright, so to start, let's take a look at our parent function. That's going to be f of x is equal to x cubed. And remember that cubed, that exponent, just means that we're going to be multiplying x by itself 3 times. Alright, so let's choose some points and let's make a graph of our parent function. So we're going to choose the points -2, or our x values rather, our inputs, -2, -1, 0, 1, and 2. Alright, so if I input those into the parent function, all I'm going to be doing is cubing them. So -2 times -2 times -2 will give me -8, because 2 times 2 gives me 8, and then I have 3 of my negative signs. So I have negative and a negative make a positive, and then a positive times a negative makes another negative. So -8, and we can go on and do this for all of these numbers. So -1, 0, 1, and 8. Alright, so let's go ahead and plot these on our graph as well. So we have 0, 0 already plotted, and then we're going to plot 1, 1, and then 2, 8. Alright, so 2, 8 is going to be up here. And then likewise, we have our negative arm, which will go -1, -1, and then -2, -8. Alright, excellent. And then we're going to just connect these with this nice, smooth, continuous curve. Now what you notice is that this looks a little bit different from any other function that we've done before. First off, if we're going to analyze this function, let's talk about the domain and range. Well, we have an arm that goes up and to the right and an arm that goes left and down. So we're going to say that our domain is going to be all real numbers and my range is going to be all real numbers. For my x-intercept and my y-intercept, it's actually the same. It both occurs at 0, 0. And these together are going to always be the same. So this is going to be my center point. And in this case, my x-intercept and my y-intercept are the same. Actually, you'll see some instances where the x-intercept and the y-intercept will be a little bit different, but we'll get to that later. Alright, so for our minimum and maximum numbers, well, we know that the domain and range go forever in both directions. So we have this arm which moves up and to the right, and this arm that moves left and down. So my minimum and maximum are going to be different, and one will occur at this function at all times. So what we say is that given any interval, the minimum and the maximum will be the tails of the function. So in this case, if I define my interval to be -2, 2, so I go from the x value -2 to the x value 2, then my minimum is going to occur at -2, and it's going to be 8. And then my maximum is going to occur at 2. I'm sorry, it's going to be -2, -8, and my maximum will occur at 2, +8. So let's just go through some transformations for this function. Remember, our transformation form doesn't change, just the function that we end up using. So f of x is equal to plus or minus a x minus h plus k. And then we're actually going to go into a little bit more in-depth version of it as well. You can do this version, which is f of x is equal to plus or minus a. And then you have b x minus h plus k. And on each of these functions, they're going to have a cube up here in this position. Alright, so let's just run through some transformations real quick. Alright, so we notice that we have our function, right? And the position, which I'm talking about for this first transformation, is going to be k. And in previous functions, we learned that k controls up and down. Alright, so k will control our up and down. So what we're going to do is we're going to take our parent function, right? I'm just going to map those points in red, our parent function points. And because our k is positive, we're just going to shift all of our points up 2. So our new function will have a point that is up 2 from all of this. So I'm going to go ahead and graph this in purple so we don't get confused up here. So every single point will just be shifted up 2 spaces. So that point is going to shift up 2 to be that point, and then this point will shift up 2, this point will shift up 2, this point will shift up 2, and then finally this point shifts up 2. And then all we need to do is connect those points, and we've completed our function. All right, so now we know that our k is going to control our graph of up and down. So it moves our up and down position. Then, likewise, we know h, right? So we know that here, h is supposed to have a negative sign in front of it. So if I see this plus here, I know that h is negative, because that negative times a negative made a positive. So this, h is going to move left and right. So h is left / right. And remember, if our h is positive, then we're going to move to the right, and if our h is negative, then we're going to move to the left. So because we have this symbol in here, we know that h has to be negative, so we're going to move our function to the left. So I'm just going to go ahead and ghost from my previous function that I just used, and I'm going to say I start at 0, 0, and then I move all of my points to the left 2. So that is my new center point. And then we go to the right 1 and up 1 from there, and then to the right 2, 1, 2, 3, 4, 5, 6, 7, 8. To the right 2 and up 8 from there. And then to the left 1, down 1, and then to the left 2, down 8. All right, so that's going to be my new function there. All right, now we're going to start talking about the differences and the things that are kind of special about the cube function. So if we plot our original points here, right? All right, so those are our original points, and now let's talk about what happens when we put a negative in this starting position here. So if this is negative, then we're going to have a reflection over the x-axis. Now we notice that we have one arm above and one arm below the axis, so they're each going to flip to the opposite position. So our new function, -1, -1, becomes -1, +1. -2, -8 becomes -2, +8. 0, 0 is going to stay right where it's at, and then our other arm is going to go ahead and do the opposite motion. All right, so our new function will be plotted as such. So that's what happens if you have a negative in front of the a. And so we can say that our plus or minus is a reflection over x-axis. And the x-axis is actually going to be moved around with our center point. So the x-axis that we're talking about is the one which always goes through the center point. All right, so now let's talk about that a and b. So you notice here we have the 1/2 inside of the parentheses. This is going to be my b position. And then we have our 1/2 outside of the x cubed in this problem here, and that's going to be my a position. So b is horizontal stretch and compression. And then A is very well known to you guys, vertical stretch and compression. All right, so I'm just going to go ahead and graph these points. And what we see is that we have to make a little bit wiser choices as far as which points we're going to choose when we have to deal with B and A. So when we're dealing with B, what we're doing is we're choosing different x values to input. For instance, in our parent function, right, we always used -2, -1, 0, 1, and 2 as my input. But now I'm going to want to choose something that's a little bit more compatible with this 1/2. So instead of choosing these points, right, I'm going to go ahead and throw out these 1/2 and 1, because when I input 1 into this function, I get 1 times 1/2 to the third. So that ends up being like 1/8. So that isn't going to be very friendly for my purposes. So instead, let's do this. Let's choose numbers which are all divisible by 2. So I'm going to choose instead 0. 0 can be divided by 2 because it's just 0. I'm going to choose -2. I'm going to choose -4. And then I'll choose +2 and +4. So when I input these, I get the numbers. When I input -4, I get out -8. When I input -2, I get out -1. When I input 0, I get out 0. When I input 2, I get out 1, and then when I input +4, I get out +8. So we see how this graph is a little bit wider than our parent function now. The same thing is going to happen when we go and use a 1/2 in the A position. So whenever you see a stretch or compress like this, especially with these compressions, where you have these fractions in B or in A, what you're going to want to do is just make sure that you're careful and choose numbers which are easy to get a nice round output for. So again, I'm going to choose, because I'm looking for numbers that are divisible by 2, right? I'm going to choose 4, 2, or -4, I'm sorry, -2, 0, +2, and 4. So I'm going to go ahead and do that. I will graph that and be right back. All right, so the same thing here, except that's a little bit less pretty. So again, it's not quite the same curve as our original function. Just make sure that you're careful when you draw your points here, because you won't have very many that will fit on the page because of the cubic function. All right, so finally, let's do an example where we have some multiple transformations. So we're going to have x plus 1 inside and then -2 on the outside. So we know that our h is negative, right, because the sign change that occurred. And we know that our k is positive because there is no sign change that occurred. All right, so our new center point is going to be at -1, -2, and then from there we can plot our points according to our parent function. All right, so then we've just got our parent function here. Be careful to make sure that you go through the points. Like you can see, I kind of missed it here, but just make sure that you actually go through the points instead of what I did. All right, so your assignment for the day is that you're going to work on Form 10-1, Form K. Also, what I need you to do is write a reflection. So write a 2-sentence reflection over what you learned in today's video. When you're done with your reflection, make sure that me, Mr. Fox, can come and see it, and I will go ahead and give you a stamp in your reflection block. If you have any questions, let me know, and have a wonderful day.